So this is going to be just like your quizzes and tests. All it's going to say is find the coordinates of the, and it's either going to say orthocenter, or it's going to say centroid, or circumcenter, or incenter. I'm just going to ask you for the coordinates of one of these points of concurrency. So you need to know, well, what special triangle segments intersect to form that point of concurrency. So for this question, the orthocenter is formed by your three triangle altitudes. So in order to find the location, the x and y value, the coordinates of this orthocenter, you've got to know the three equations of these altitudes. So that's step one. Now, what I always do is I draw a quick sketch of what this triangle is going to look like. You do not need to extremely accurately, with graph paper, graph these triangles when you're trying to find these orthocenters or circumcenters or whatever. You just need a sketch and an idea of, okay, this vertex is opposite this side, so on and so forth. So what I'm going to do is, I'm just going to look at my coordinates. I'm going to get an idea of what this triangle is going to look like. First off, let's just say that this was my origin. The x marks the spot. That's my origin. Then x, it's going to be the x value, the x coordinate of point x is 0. So it's not going to go to the left or right any, but it's going to go up 4. So I know that x is going to be up here somewhere. Then if I look at z, kind of the same thing, but it goes down. So it's not going to move left or right at all, but it's going to go down 5 units. So z is going to be over here at 0, 5. And then y, if I start here at the origin, it's going to be going over 2 and then up 2. So this just gives me a rough idea of what this triangle is going to look like. And if you sketch it accurately enough, you should get an idea of, okay, this slope should be positive because I see that it's positive, or this slope is negative, so on and so forth. But you do not need to get graph paper and accurately graph these. This is just a simple, what? Oh. Okay, so it's right, but it's not. Okay, so make sure you have it copied down right. Okay, cool, thank you. So anyway, so I always do a quick sketch just so I know what this triangle kind of looks like, okay? From there, you need to figure out what are the equations that you're looking for. Well, if it's the orthocenter, we're trying to find that we need the altitudes. So I know that I'm looking for the altitudes. Then you need to run through your head, well, what's the definition of an altitude? What is an altitude? Well, it goes from vertex to the opposite side and is perpendicular to that opposite side. So that's their two facts. I know the point that it goes through and I know the slope. So what I do, this is just how I solve like a lot of these problems. Since I know that these altitudes have to start at the vertex, I just write those points. So I know that one of these equations is going to have to go through the vertex x, and one's going to have to go through y, and one's going to have to go through z. So I just write all three of these, and I've made these 3 columns. Now I'm doing them in different colored ink so you can see the different altitudes, but obviously you're going to be all in pencil. But these 3 columns are where my altitudes are going. This is where I'm going to write these equations, because I know they have to go through the vertex. Now I need to figure out what are the slopes. So the altitude that starts at the vertex x and goes to the opposite side, I need to know its slope. Well, the opposite side, if I just look at my little quick sketch, would be segment zy. So I need to determine what is the slope of zy. So cursive lowercase m for slope, that's what we use. And then this here is like subscript notation. It's like in the formula, in the point slope formula, you have y minus y sub 1. It's just a little notation to keep everything clear and so that your reader knows what you're talking about. So this is the slope of segment zy. Because we need to find the slope of the opposite side and then take the negative reciprocal so we know what the slope is that's perpendicular to that side. So here we go. So the slope of this segment here, obviously it's positive. My rise, that's the change in y, that's my numerator, correct? It starts at -5 and goes to +2. What's my rise? 7. My run, it starts at 0, goes to positive 2. What's my run? 2. My slope is 7/2 of this side. But for the altitude, I need the slope that is perpendicular. So I'm going to put slope perpendicular is equal to, what is it going to be? -2/7. -2/7. Once you have a point that this line goes through and the slope of this line, that's all the information you need. You plug this information into your point slope formula, which is y minus y1 equals m times the quantity x minus x1, where x1 and y1 are the coordinates of the point that this line has to go through, and m being your slope. Well, you have that information, so just plug it in and simplify. So it's going to be y minus 4 equals -2/7 x minus 0, and that's in parentheses. So what's the first thing I have to do? You got to distribute your slope first. Then you can get that variable y by itself. In the end, your equation, when you're done simplifying, of this altitude from point x is y equals -2/7 x plus 4. Any questions about this first altitude? Let's go to the second one. The second one is starting at y, and it's going to the opposite side, and it's got to be perpendicular to it. So we need to find the slope of the side that is opposite it. The side that's opposite is segment xz. What is my rise? If I start at z and go to x, what's my rise? Starts at -5, goes to 4. 9. What's my run? Starts at 0, ends at 0. Can we divide anything by 0? So what's the slope of segment xz? This is undefined. It's a vertical line. Undefined. So we need to figure out what is the slope that is perpendicular.
0.
Everybody should say that extremely quickly, 0, because we just got done with 4 problems as a warm-up dealing with these types of lines. So now you have your slope, you have a point that it goes through. So plug it into the point slope formula. I know that if a line has a slope of 0, that's a horizontal line, and the equation is in the form of y equals some constant. You figure out that constant, or that value, by depending on what point it goes through. Well, I know that my y value is a +2, so I know that y has to be 2. This is the equation of my second altitude. Any questions? Moving on to the third altitude. Same process. You gotta know the slope of the side that's opposite it, so that would be segment xy. So let's find the slope of segment xy. It's clearly negative, okay, just because I've already sketched. My slope, it starts at 4 and goes to 2. So my rise is a -2. It starts at 4, goes down to 2. My rise is a +2, however, and this simplifies down to a -1. Does everyone agree that the slope of this side is -1?
Yes.
Okay, so what would be the slope that would be perpendicular to this? It'd be a +1. I have my point, I have the slope, so plug it into the point slope formula. So when I plug that in, it would be y plus 5 is equal to 1 times x minus 0. Please make sure that when you plug it into this point slope formula, you are subtracting whatever the value of y1 is. Well, the value in green for this altitude, the value of y1 is a -5. So when you subtract -5, it's like adding a positive. Okay? So we get that y, in the end, when you're done and simplifying and after distributing and all that fun stuff, you get that y is equal to x minus 5. Oops. Okay, the x is x minus 5. That is the equation. Y equals x minus 5. All right. We're not done though, because have we found the coordinates of the orthocenter?
No.
Not yet. But we have the equations of our 3 altitudes. So let's just pump the brakes here. Questions about this? What's on the board currently? Finding the equations of altitudes. Okay. Now, I need to see where these three lines intersect. So this is now we have to do a systems of equations, and we have to solve that system by using substitution or elimination. There's always going to be a path of least resistance. Okay, you can choose to go the hard way, but there will always be an easier way. For this one, substitution's the way to go, by far. Substitution's the way to go, because we already know that y is 2. So all we have to do is substitute. We're going to replace y with what it is equal to, 2, and then you can solve for x. So if y is 2, then what's x going to have to be? 7. So that didn't take much work, but you would show work by saying this. Plus 5 on both sides, x is equal to 7. Your final answer needs to be in the appropriate format. Meaning, in the end, what are we searching for? We're looking for a point, right? We're looking for the coordinates of a point. The orthocenter is a point. So your final answer needs to be in point notation. So, it would make sense to call this point O, because this is the orthocenter. But you need to have whatever you decide to call it, whatever capital letter you use to represent the orthocenter, followed by open set of parentheses, your x value, which in this case is 7, your y value, which in this case is 2, and then close it with, have a closed parentheses. This is what your final answer needs to look like. It's asking for the coordinates of a point, so make it look like that, the coordinates of a point.